Hello everyone, this is Ashwini from Cheenta.com. In this video, we will work on geometry from Math Olympiads. And this particular problem is fascinating. It asks us to find a point with a certain property within a triangle. I was discussing this problem in our Math Olympiad live class course. You can check the link in the description for that course if you want to join it for IOQM, AMC 10 and similar contests. It's also useful for ISI-CMI entrances. Let's quickly tell you what is the statement of this problem. It says that D is a point inside the side AB of triangle ABC. We want to find a point X. So you have a triangle ABC. D is a point on the side of the triangle. D is here on AB. We want to find a point X. So maybe X is somewhere here. X is on BC, such that XAD, the area of XAD and the area of CAX, these two areas are equal. Remember, the point D is given, so you can't change the position of the point D. You can study specific positions of point D, but once you fix D, it's a constant, it's fixed. Depending on the point D, you need to find out the point X. The X is something that you want to find, such that these two pieces, XAD and CAX, are of equal area. So, the only concept that you would need to actually solve this problem is that the ratio of areas is equal to the ratio of bases. I'll quickly talk about this particular concept. It's very simple. It basically says that if you have two triangles, let's say ABC and AXY, there are two triangles, ABC and AXY. Okay, and they are standing on the same base. So the line on which the bases are, this is the same straight line. And maybe they share a vertex. Maybe they share a vertex like this. Then the area of triangle ABC divided by area of triangle AXY is equal to the ratio of their bases. Ratio of their bases. So, if you drop a perpendicular, let's call it H. Notice that both of these triangles have the same height, H. Right? So, what is the area of triangle ABC? Well, it is half H into BC, half base into height. And area of triangle AXY is half H into XY. So these two things cancel off and you get BC over XY. Right? So that's the main concept. That is, the ratio of areas of the two triangles ABC and AXY is equal to the ratio of the bases BC over XY. So while we discuss this problem, we will talk about a very powerful problem solving strategy. It's called test with special cases. So here is a strategy: test with special cases. The reason this is very important is because once you test with special cases, you may know how to solve the general case. It's a strategy. So let's see how that works in action. Okay. So let's take this little triangle and put it here. Now assume, let's remove this. Let's test with the special case when D is midpoint of AB. So D is here. So if the D is the midpoint of AB, can you find X such that ADX and CAX, ADX and CAX have the same area? What is the position of X such that that happens? Well, let's see. So if D is the midpoint of AB, suppose this piece is alpha, the area of ADX is alpha, then area of BDX is also alpha, right? Area of BDX is also alpha. Why? Because this is the median. So area of these two triangles is equal to the ratio of their bases, which is 1:1. The two areas, the bases are equal because AD and BD are equal because D is the midpoint of AB. Therefore, these two areas are also equal. You can also remember this like this: the median of a triangle splits a triangle into two pieces with equal area. Okay? Alright. Now, let's assume that we found X. So it's very important. Whenever you need to find a point X with certain properties, the strategy is that you assume that you found X. You assume that you found X, and then you study the properties backward. It's sort of back calculation. So I'm assuming that we found X. Okay? So if we found X, then XAD and CAX are of equal area. So CAX is also alpha. Okay, that's great because XAD is alpha. That's what we started off with. So now, what is the ratio of areas of triangle BDX and triangle BAC? BDX and triangle BAC. BDX is this, BAC is this, and BDX is this. Okay, so here we will be using a little bit of insight from trigonometry. Actually, this is also an insight from geometry, that area of two triangles which have one angle in common, their ratios of areas are actually product of sides. So this is equal to, this ratio is equal to BD times BX divided by BA times BC. The ratio of areas is BD times BX divided by BA times BC. This works for any pair of triangles with one angle in common. You just have to make the product of the two sides which has that angle in common and take the ratios of that. So can anyone tell me why this is true in the comment section? There is a little bit of trigonometry that can be used. It can be done without trigonometry as well. Okay, so what is BD over BA? BD over BA is 1 by 2, right? Because D is the midpoint of BA. So, and what is BDX over BAC? BDX is alpha. BAC is 3 alpha. So what 3 alpha? Because alpha plus alpha plus alpha. So 3 alpha. So 1/3 is equal to half times BX by BC. So 2 by 3 times BC is BX. Okay, we found X. We found X. It's awesome because that's all we need. We now know that to find the point X, we have to just divide BC into 2:1 ratio. You have to divide BC into 2:1 ratio. This is 2/3, this is 1/3. So now we know how to exactly find out the point X. Right? Awesome. So now we also know what happens if D is any point. We just found it for D is the midpoint, but we can now generalize easily for the case where D is any point. So what happens if D is any point? So if D is any point, instead of, so what we used here is this is 1:1, right? Instead of that, we can just assume that it's m:(n). Some number is to some number. Now you may have a little lingering doubt here. What if D does not divide perfectly, like in integer ratios AB? That's totally fine. Whatever the length of AB is, so you can assume that one of them is 1 and the other one is some number T. It doesn't really matter. All that matters is that we have to write down m:(n). All that matters is that we are able to split AB into some ratios of two numbers. That's all that we need. We need the ratio BD is to DA. That's all that we need. Okay? We don't need m and n to be integers. We don't need m and n to be integers. We just need the ratio BD is to DA, and that we have. And so let's see how we can work that out. So we have ABC as a triangle again. Okay, so ABC is a triangle. And we have D as the point, which divides this into m:(n) ratio. And we will again pretend that we have found the point X. Pretend that you found X. So if we found X, then this is, if this is alpha, if this is alpha, then this is also alpha. Question is, what is BDX? Well, we know that triangle BDX divided by triangle ADX is m by n. That is BD over AD, m by n. And ADX, I know, is alpha, right? So triangle BDX is m alpha by n. This is m alpha by n. Okay, all right. So we will use the same strategy as before. So triangle BDX divided by triangle BAC is BD times BX divided by BA times BC. BD over BA is M over M plus N times BX over BC. And this BDX over BAC is M alpha by N divided by M alpha by N plus alpha. BAC is M alpha by N plus alpha, right? And this is what it is, okay? So what we have is that M by M plus 2N, M by M plus 2N is equal to M by M plus N times Bx by Bc. So MM cancels. So we have M plus N divided by M plus 2N is equal to Bx by Bc, or M plus N divided by M plus 2N times Bc is Bx. Okay, we found the value of x now. Because we know M, we know N, we know M plus 2N. So we can just take that ratio and split Bc in that ratio and you can get x. I hope you learned something from this particular exercise. There is number one, ratio of areas equals to ratio of bases. Then the strategy of using a special case so that we can move on to a general case. And then that beautiful formula where ratio of areas of triangles is ratio of product of two sides containing the equal angle. All of these things, all of these ideas come in one place. You know, geometry problems like this makes you wonder that how different parts of geometry can come together in one place and create a beautiful idea. So I'll see you in the next video. Thank you for watching and continue doing great mathematics. Take care. Bye.